Alright, remember in lecture we went through this demonstration which you have a tube shaped like this, narrower in the middle and wider at the side. When the air is not flowing, the water level is the same for both of the water tube down here. What happens is that when you let air flow through, the air has to speed up to pass through the narrow region, which means that the force at this region on the air should be going to the right. That's how the air got speed up, because the net force on the air is pushing it and accelerating it to the right. But then the air have to slow down again as it goes to the wider region. So the force at here on the air should be going to the left. So this means that the air pressure should be higher at here and lower in the middle. So that's why the total pressure is creating a net force. The net force created by the pressure difference is going to the right, and this region is speeding the air up, and then it go back to higher pressure, and that is acting a net force of going to the left on the air and slow down as the air go from narrow region to the wider region. So because the center has a lower pressure, the water will be sucked up, and the surface of the water will be higher in the middle. That is what we see in the lecture. What we can do is that when the air is flowing, we add a piston on the top of the center water that creates more weight on the water, and it can push down the water until all the water are back to the same height. So if we do that and we turn off the air, what happens is that the center one will go down without the help of the pressure difference on the air from the air on the top. So if we have this piston, then when we turn off the air, the center one will drop down, or the one connected to the narrow region will drop down. Same thing at here. When the air is flowing, we can adjust the weight of these two pistons such that the water level is the same. But when we turn off the air, the one connected to the narrow region, the one connected to the narrow tube will drop down. So we know this one will drop down, and the right piston will become higher. Okay, so we can analyze the pressures. Let's say this water height is h. At this point, the pressure should be the same due to Pascal's law, because the y position is the same, and it is a static water, so we call that P. And for the scenario when the air is flowing, we can call this P prime. And the air pressure will be the same when the air is not flowing. Let's call it P air. And the mass of the piston will be, let's call this M1, and this M2. And the area of the piston can be called A1 and A2. So let's look at this piston and the water down here. Together, there's a total mass of the piston plus the mass of the water, density times the volume. So this is a total gravity acting on the whole thing. And there's force from the air on the top, pressure times area. And here's force from the bottom. Pressure down here is P times area. So from this free body diagram, you can get that this upward force should cancel these two downward force. So P times A2 should equals the pressure, air times A2, plus the gravity on the system. And you can analyze the free body diagram for the three other pistons. This one, if you pressure from the bottom cancels the pressure from the top and the gravity of the piston. There's no more water here, so we don't need to add the gravity on the water. This tube also doesn't have the water, but we can call this pressure here P1 and the air pressure here P2. Then the free body diagram after Jordan will tell you that this one should be 1 because I'm looking at here A1. So here we can look at, let's go back to A2. You have pressure number 2 and no more water because the two pistons have the same height. And for the piston on the left, piston number 1, the pressure on the top for the air will be different. So we call that P1. Alright, so starting from these 4 equations and the fact that we have a this equation telling me that if I sum up pressure, potential energy, here I'm looking at the air, so I have to use the density of the air, and the kinetic energy equals a constant. If I sum up the 3 terms at this point and this point, they should give me the same answer because these 2 points have the same y position, so I can ignore this term. And now I can just get that. So the pressure time plus potential energy plus kinetic energy becomes a fixed total energy. And if I want to compare the pressure between these 2 points, I only need to care about the pressure terms. So the pressure at point 1 plus 1/2 density of air, the speed at point 1 squared should equal to pressure 2 plus 1/2 rho air V2 squared. And from continuity equation, we know that because this density, this diameter is twice at here, so the speed at here will be, if the speed here is V, is V2, it should be proportional. Alright, so let's do, let's call this small a 1 as the area at here, and then A2 is the area at here because I already used big A for the area here. So we know A1 V1 should equals A2 V2. That is continuity equation. Now, because the D1, the density, the diameter here is half of the diameter here, so this means A2 is 4 times bigger than A1 because the area is proportional to diameter squared. So if A2 is 4 times bigger than A1, I can replace it by 4A1, cancel A1, and I get V1 is 4V2. So plugging in here, I get the pressure difference. Let's make it positive, so pressure 2 is bigger. So let's do 2 minus 1 equals 1/2 rho air, and I move 1 to the other side, so V2 to here, V1 squared minus V2 squared. And indeed V1 is bigger, so this is positive equals positive. So now from this 4 equation, or 5, V1 equals 4 V2. We can solve for the water height over here, or how high will be the right piston compared to the left piston. So because I know the key is the pressure difference, I'll try to get them. All the pressure here have area by the side, so let's divide the area out. The first equation becomes P equals P air plus M2 over A2 G here is also A2. So here I have density of water, height of the water here plus G. And here I have pressure equals Pn plus M1 over A1 G. Here I have P prime equals P2 plus M2 over A2 G. And from here I have P prime A P prime equals P1 plus M1 over A1 G. Now, to get P2 minus P1, I subtract these two to get P2 minus P1 plus these two terms subtracting each other equals P prime cancels P prime equals 0. So these two equations give me that P2 minus P1 should also equals the M1 over A1. I move it to the other side so I get a minus sign which result in the swapping of the order G. Now when I look back to these two equations, I can do the same trick. I can subtract them and get PP cancel, air cancel. These two terms subtracting, let's do 1 minus 2. So I get 0 equals 1 minus 2, because 1 minus 2, so this is negative, minus rho WHG. So from these two, I get this combination equals something related to the height of the water, and it also relates to the pressure difference. And I do know the pressure difference over here, so we're almost there. Let's raise them. So combining these two, I get this thing. I can move the minus term to the other side. Density of water, height times G equals this combination of the mass of the piston over the area. And that equals also the pressure difference, which I know is just this thing. And now I'm going to plug in V1 is 4, V2. So now I have 16 V1 squared, V2 squared minus V2 squared. So at the end I have 15 over 2 rho air V2 squared. So the height of water is here. The thing I need is here. The height of water will be rho WG to the other side, 2 rho WG, and the top will be 15. Density of air, the speed at second 2 will be here. So the speed at the wider part square. Now, if I plug in the numbers, I forgot what V2 I gave you. Let me go grab the solution. So the number I gave you is the speed at the left side of the air pipe is 30. So this is 30, which then I have to convert to V2. So maybe I should do the thing differently. V2 is 1 over 4 V1. So here I should do V1 minus 1/16 V1. So now I have 32 and 15, and then this is V1 squared. So 15, 32, density of air is 1.2 kilogram per meter cube, density of air is 1000, G is 9.81 meter per second square, speed is 30 meter square, and now I have to go grab my calculator. So put those numbers into the calculator. You get 0.0516 meter, which is 5.16 centimeter. So that's how you do this question. Can you see that? No? So plug those numbers in. This is 0.0516 meter, and that is 5.16 centimeter. Can you see that? Yeah, okay.